All right, today in topic 23.2, we're going to talk about a little bit more about nets from yesterday and talk about what a platonic solid is and what their nets look like. So on your homework yesterday, you had to create a net for a house. And so let's talk about different, if you look at your classmates' different nets that they came up with. Question number 1 in your notes today, it says, which net would you use if you wanted the container to have the strongest possible bottom? Well, for the bottom to be the strongest, okay, so if we look at a net and we're looking at the floor, for it to be the strongest, so the floor that's going to have the most stable and be the strongest is the floor that does not have any cuts around it. So notice how these are all folds right here. You would be folding up the sides and the walls. So that would create the most strongest, the stable floor. If you had cuts, like if this back wall right here, if this had been the floor, you have a cut right here, and so that wouldn't be very strong. So the strongest one would be the one that has no cuts around the floor. So that would be your answer for question number 1. For question number 2, it says, which net for the house would you use if you wanted to use the least amount of cardboard? So the least amount of cardboard would be used when we would make a net that closest resembles a rectangle. So here's an example of one that would use the least amount of cardboard, and we wouldn't have as many cuts to make. Okay, you can kind of see that, just the shape of it gives you a rectangle. All right, so let's talk about a platonic solid. So think about a cube for a second and what a net for a cube looks like. It says it's the easiest of all of them to make because all of the sides are squares. They're all regular polygons. Well, that is special when we talk about three-dimensional figures. Three-dimensional figures whose faces are all congruent regular polygons is what we call a regular polyhedron. So a regular polyhedron is a three-dimensional object whose faces are all congruent regular polygons. So let's talk about what a regular polygon is again. So regular means all of the sides are equal and all of the angles are equal. So equiangular and equilateral. There's only 5 that exist, and they are called a tetrahedron, a hexahedron, also known as a cube, an octahedron, dodecahedron, and a icosahedron. So we're going to go through the animations and fill out this chart in your notes as we go. Real quick, I'm going to have you change this. We're going to put where it says element, we're going to change that to face shape, and I'll explain that when we get to that. All right, so the first one, the first platonic solid, and these are pretty special because, like I said, there's only 5 that exist in the world. So the first one, the simplest one of all, is using equilateral triangles, and this is called a tetrahedron. And so when you to make a 3D shape of a tetrahedron, it is 4 equilateral triangles. So in your notes, where it says the number of faces, there's 4 of them. Okay, the reason it says it's called a tetrahedron is because tetra in Greek, the prefix means 4. So tetrahedron, and these are all called polyhedrons. So a tetrahedron is a 3-dimensional shape that has 4 equilateral triangles. So we'll put tetrahedron here. And then under where it says face shape, we're going to put that it's equilateral triangles. So all 4 of these triangles are the exact same triangle. So even though this bottom one right here doesn't really look like it might be the same size as this, it is. Okay, all 4 of these triangles, these 3 here and the one on the bottom, are all congruent triangles. All right, the next one is what we call an octahedron. Okay, it is made up of 8. Octo means 8, so there's 8 faces, and they are also equilateral triangles. Okay, so this is an octahedron here, and this is also equilateral triangles. So we have 8 congruent equilateral triangles that make up this figure. So you've got 4 here, and then you have 4 on the bottom, and they're just kind of put together. We don't look at this because this is not a face, even though that's a rectangle. That's a cross section. That's not a face. All right, the next one is also made up of equilateral triangles. This is called, we say it's an icosahedron. Okay, icosa means 20, and so this is 20 equilateral triangles. Okay, so all 3 of these are special because they are made up of equilateral triangles. And you'll notice there's no gaps, there's no overlaps. Okay. All right, then so those first 3 that we looked at all had equilateral triangles. The next one is called a hexahedron. Okay, it's made up of 6 squares. Hexa means 6. Okay. Oops, I missed the D, sorry. And I'm going to put right here, we're going to write cube. All right, so the other name for a hexahedron is a cube. And this is, again, special just because all 6 faces are the same square. All right, and then the last one is a dodecahedron. Dodeca means 12. So this has 12 faces. And these faces are regular pentagons. Okay, so you've got dodecahedron, and these are pentagons. Okay, and of course they're all the same. So all 12 of these are the exact same pentagon. All right, so here are the 5 Platonic solids. They were named for the Greek philosopher Plato. Okay, that's why we said they're called Platonic solids. The first part of that's Plato. And this next part, and I kind of took this out because it really doesn't really have a whole lot to do. You're not gonna miss out on anything by really not knowing this, but I want to go ahead and mention it. So it just talks about how he believed that the 5 basic atoms in the universe were fire, water, air, earth, and cosmos. So it just says that fire, air, and water react with each other, and so they must be composed of similar atoms. So that's the reason why these are all triangular faces, because they all react with each other. Okay, and so for them to be, he said, because they're similar, they all would have equilateral triangles. He also said that the fire atom is the lightest, and he says because it has the fewest number of faces. And then he said the earth is a cube because the earth and a cube are the most stable. And then he says that the dodecahedron is cosmos because it's different than the others, and that and then it's so different from earth. So this is not anything we're going to test you over, this right here on the elements, which is why I took that part off on your notes, because it's more important to know what face that each of these is made up of. So we've already written this down in your notes. Hopefully you wrote it down. It says, what's another name for a tetrahedron? And that would be the cube. Okay, so let's just review these one more time. Your tetrahedron, your hexahedron is a cube. The tetrahedron would be a triangular pyramid. Okay, so for this right here, it says, what's another name for a tetrahedron? This is just called a triangular pyramid because the base is a triangle and your faces are all triangles. All right, then you've got your cube, which is your hexahedron. They're made up of 6 squares. You have your octahedron, 8 triangular faces. You have your dodecahedron, 12 pentagonal faces. And then you have your icosahedron, which is 20 triangular faces. All right, in your homework today, you're actually going to cut these out and fold them together. So you've got your nets for the 5 different ones. Okay, you're going to cut them out and tape them and fold them together. And then you're going to take a picture of those, and that's what you'll upload into your Google form. Okay, so there they are. The dashed lines represent where you'll fold it. Okay, so that should help you when you're kind of folding it together to create those platonic solids.